Hello everyone. In this video, we will learn about naive-Bayes classifier. Basically, naive-Bayes classifier is based on Bayes theorem, which we have seen in the previous video. And it is, what is this Bayes theorem is? It gives the conditional probability of an event A given event B. So this is the equation for Bayes theorem. So naive-Bayes classifier is based on Bayes theorem. So before going on to this naive-Bayes theorem, you need to understand what is meant by machine learning. So machine learning is a type of artificial intelligence. Basically, it is focused on building computer systems that learn from the data so as to improve their performance over time. There are various types of machine learning. One is supervised learning, then unsupervised learning, then reinforcement learning. So what is the supervised learning? We will concentrate on supervised learning because we are going to use naive-Bayes classification. So that is a supervised learning algorithm. So in supervised learning, what is happening is the models are trained using labeled data set. So the data set will be given and it will be labeled form. So the model learns about each type of data. So what is happening is from the labeled data, here you can see from the label, this is the labeled data. So the labeled data is fed into the system and it is from the given complete data set. What is happening is 60 to 80% of the data is being taken for training the model. So that too, this labeled data set is given for training the model. So once this model is trained, then we'll be using the remaining data from this given data set, that is called as the test data set, to check whether the model is performing, the prediction is proper or not. So once the model is trained, here you can see the labels are like this. Here so many shapes you can see here. So it here in this you can see a hexagon, then square, triangle, and also what we do is the labels. So in the data set you have several shapes, but for each shape there is a label given. So hexagon, square, triangle. So here in this one the output should be the model should predict it as hexagon, square, or triangle. So even when you are giving a new shape to the model, then it should predict the shape, what shape it is, that one. So based on that we are actually training the model. So such type of problems you can call it as you can take it as a classification problem, or so supervised learning can be of you can use various algorithms for the supervised learning. One type of algorithm is regression algorithm, another one is classification algorithm. So when we will use this regression algorithm, so regression algorithm we can use when there is a relationship between input variable and output variable. So if there is a relationship between input variable and suppose this is y is equal to mx, this one is an input variable and this is an output variable, you can see there is a relation. So if there is a relation which is existing between input variable and output variable, then we can go for this regression type of algorithms. Basically this regression algorithms can be used for the prediction of continuous variables such as for weather forecasting, then market trends, etc. But in the case of classification algorithms, when you will be using, when you want the output to be output variable, it is in the categorical form, or that means there can be certain classes like yes or no. The output can be yes or no type of answers, or it can be male, female, or it can be true, false kind of thing. So if you want the output to be of such categorical nature, then you will be using classification algorithm. So this naive-Bayes is the most commonly used classification algorithm. So we'll see what it is, how it is being done. So as I already said that, naive-Bayes classifier is based on Bayes theorem. As you know that it is a probabilistic framework. And, when a data set is given, there are various attributes. Okay, so the attributes are given. You will be given a data set with several attributes and you have to predict the class. For example, in the example, the previous example I have shown, for you have various shapes and you have to predict the shape, whether it is square, triangle or not. Or you have various data set where in which you have to predict the class, whether it is yes or no, or maybe male or female. So what we want to do is we want to find the value of C. What is the C? C represents the class. It can be yes or no, or male or female, like that. So we will be finding the value of C which maximizes this probability. What is this probability? So from Bayes theorem, you know, this is the Bayes theorem as we have already seen. So this is the conditional probability. You can see this is the posterior probability. So the conditional probability, and here this one in the numerator you can see this is this A1, A2, etc. represents the attributes and C represents the class. Okay, so what we actually do is we'll be finding this one for each attribute. So P of suppose C given A1, then you will be finding that one, or then you will be finding P A1 given C. So this values we are finding. So what we will be doing is we will be finding the value, the probability, which probability is maximizing this probability, this one, which value is maximizing this probability. So we will be choosing the value of that C. So which value is giving? Suppose C, as I said, it can be yes or no. So whether for yes or no, the probability is giving the maximum value. Depending upon that, we will be choosing which class it is. So what we do is we'll be finding all the probabilities. Then we'll be choosing the value of C, which gives maximum, the probability, whichever value probability is maximum, and that particular C we will be selecting as the final classification. So basically when you are using this one, you know, what I said is we are finding this one, it is nothing but we are actually, because it is directly proportional, you can see when you are maximizing, choosing the value of C which maximizes the probability of this one, this is nothing but it is maximizing this probability also. If this is maximized, means this is maximizing this probability also. So the total, the numerator also, it is getting maximized. So we ignore the denominator. Why we ignore the denominator? Because it is constant for all the classes. So when you are basically applying this naive-Bayes classifier, we consider only the numerator part. So here this denominator part we ignore. So that is how we you know, so how it is being done is, you know, we are assuming that there is independence among attributes. Then when the class is given, so probability of this one is, you suppose you want to find the probability of all the attributes given C, that is probability of A1 comma A2, A1, A2, A3, etc. are what? That are the attributes, that is a column heading in the given data set. So the given class, or how you can do find this probability? So it is the product of individual probability. So you will be finding the individual probability, that is probability of A1 given C, that particular class, and probability of A2 given that particular class. So all the products you will be giving you this answer. So that is what we will be finding. We can estimate probability of AI given Cj for all AI and Cj. So this, you know, this point is classified to that particular class if that particular probability, this value is maximum. What is this one? This is the original class probability and this is the conditional one. So when you take the product of these two, whichever class is giving the maximum value for this product, that is the classification we will be choosing. So I will explain this with an example so that you can clearly understand how it has been done. So let us have an example here. This is the attributes are, you can see chills, runny nose, headache, fever, and the last column you can see flu. So this is you can see when you go through this last column, you can see the values are N, Y, Y. So this actually what we are trying to do is you are going to classify yes or no. So we can use this naive-Bayes classifier because the last column. So what is this flu? Yes or no? So we want to predict whether a particular person is having flu or not. So if the person is having flu, then it is yes, otherwise no. So what are the conditions? So for a given sample data set, that is X, X may be the combination of this chills, this runny nose, all these attributes, it will be given. So for the given set, you are going to predict whether the particular person is having flu or not, because as you know that this Bayes theorem is based on conditional probability. So naive-Bayes classifier is based on Bayes theorem. So this is based on conditional probability. So given this condition, what prediction you are going to get? So let us consider that, you know, as I already said, there are two classes, yes or no, flu, yes or no, that those are the classes, the last column of this one. Then the data sample given is X, that is X. So chills is equal to y, runny nose is equal to n, headache is equal to mild, fever is equal to y. So this is the data given to you and you want to predict, given this condition, whether the person is having flu or not. So the conditions given us, chills is equal to y, runny nose is equal to n, headache is equal to mild, fever is equal to y. So we can predict this whether this particular person, if he is having chills, yes, runny nose, no, headache, mild, fever, y, whether that person is having flu or not, we can predict using naive-Bayes classifier. So the first step is you have to find the probability of this flu, yes or no. So the step one is you need to find the probability of flu. So this is the data set given. So from this column you can find the probability of flu. How many tuples are there? First you need to count it. 1, 2, 3, 4, 5, 6, 7. There are 8 tuples given. So 1, 2, 3. So this is 8. So 8 tuples are there. Out of that you just see the last column. So in the last column, how many S are there? So here this is S 1, 2, 3, 4, 5. So you can see in this last column you have flu S. 5 tuples are with yes, and so remaining 3 are with no. So the total number of records, so the total number of tuples you have it as 8. Then the number of tuples with S labels is 5 and the number of tuples with no labels are 3. So you got this one, number of tuples with S and number of tuples with no labels. So this one, the last column represents the labels. So as I already said, supervised learning is based on labeled data set. So this is a labeled data set. Now we will be finding the probability. So what we are supposed to do is we have to find the probability of flu. So probability of flu is what this basically what we are doing, we are classifying it as y or no. So this is the classification we have. So what is that classification? We can represent it as CI. Let CI represents the classification. I is equal to 1, 2 because only 2 classifications are there. So probability of CI, how will you find the probability of CI? We want to find the probability of flu yes or probability of flu no. So probability of flu S is what? How many tuples are there with S? We have 5 tuples with S. Out of how many total tuples? 8. So 5 on 8. So what is the probability of flu is equal to S? That is 5 upon 8. That is equal to 0.625. Now how will you find the second classification? That is the probability of flu is equal to no. How many tuples are there with no? There are 3 tuples in the last column. You can see there are 3 tuples with no classification. So flu no is 3 divided by the total number of tuples 8. So you will be getting it as 0.375. So now you got the probability. So what is in the equation? You can see here which probability you have found it actually. So this value you have already found, that is the probability of C. Now what is remaining? You need to find this one. Okay, so we found P of C, that is the probability of C for both the classes, that is S and no. We found it as 0.625 and 0.375. Now what is the second step? We need to find the probability for each attribute from the given data set. Okay, so what is it? X is given, you know, X is what is X? X is chills is equal to Y, runny nose is equal to N, headache is equal to mild, fever is equal. So what we have to do, we have to consider each attribute separately. So what we do, chills Y, we will be checking for both the classification. What is that? Flu no and flu S and flu no. Similarly, you will be finding the probability for runny nose is equal to N for flu. Given flu is Y and flu is N. Similarly, you will be finding probability for headache is equal to mild. Given flu, Y and no. Here similarly, fever is equal to Y. Given flu, Y and N. Why this flu, Y and N? Because those are the 2 classes which we have considered. So how many classes are there? For each class you need to find from the given data set, that is X is equal to. So first we will be considering chills is equal to Y for flu, Y and flu no. So we'll be considering both. So chills is equal to y. As I said here, you can see chills is equal to y given flu is equal to yes and given flu is equal to no. So how will you find this first probability? Already given flu is equal to yes. So which is the flu is equal to yes? 1, 2, 3. These are the tuples with flu. Yes. In this you need to find, so how many S are there? 5 S are flu S are there. Out of this, what we need to find in the chills column, chills Y is given in the data set. Okay. So given data set is chills is equal to Y. So how many data sets are there with chills Y? So you just see here, these are the data sets with chills Y. Out of that chills Y, how many are having flu S as answer? So you can see this one is flu S is there. This is also flu S is there. And this one is also flu S is there. So how many chills are there? 1, 2, 3. So probability of chills is equal to Y given flu is equal to S. How many are there total tuples? Total in chills you have 3. Out of how many Y are there? Here you have 5 Ys. Okay. And here you got 3. So the probability is 3 divided by 5, that is 0.6. Now similarly you can find chills Y and flu no. So how many are here for the flu no? Here you can see this one is I'll put a double arrow here. Flu no is this one and this is flu no. Okay. So in this case, chills Y, you need to consider only chills Y because it is a given data. Chills is equal to Y is given. You can't change it. Chills is equal to no. So chills is equal to Y and flu no. How many are there? Here you have 1. Then we have only 1. 1 on how many are there? For no, no is 1, 2, 3. So 3 tuples are with flu no. So out of with no, how many are chills Y with no outcome? That is only 1. So 1 by 3 is the probability. So it is 0.33. Similarly, the second set, what is that one? Runny nose is equal to N is in the given data set. So runny nose is equal to no. So you just go to the second column and find in a similar manner runny nose is equal to no, but the flu should be S. So we need to test for both the classification, that is flu S and flu no. But this one is a given data set is runny nose is equal to N. So runny nose is equal to N. Here you can see 3 tuples are there. So in this 3 tuples, how many are there with S? You can see this is S. Then you can see only 1 is S. So how many S are there total tuple? 5. In the flu column, you can see there are total 5 S tuples. So in the runny nose, there is one no, which is giving yes as the flu. So the total probability is 1 by 5. Then what about this runny nose no? Runny nose no, in that the tuple which is having flu no, here you have 1, that is flu no. This is not this one, and here also it is, this one is also flu no. This is also correct. This is runny nose is equal to N and flu is equal to no. So how many are there? How many flu no's are there tuples? So flu S tuple is equal to 5, no tuple is equal to 3. So out of that, how many are there runny nose no and flu no? It is 2. So 2 divided by 3 because it is for no. So 2 divided by 3, you got it as 0.66. Similarly, headache is equal to mild, that is a given data set, and flu is both the classification, flu S and flu no. So now you go to the next column and headache is equal to mild. So headache is equal to mild. How many rows are there? 1, 2, 3. Now you need to see how many are there with S. So this is S. Okay, this is S. Here also it is S. So how many rows are there? 2 rows are there with mild and S. So 2 divided by 5. Divided by 5 because 5 S are there. Flu S is 5. So 2 divided by 5, you got the answer. Now check the mild and with the flu no column. So how many are there? Now this is there, that is no column. I'll put 2 ticks. And mild, okay, only 1. So we can see 1 divided by, so only 1, and here divided by no means 3. So 1 divided by 3, you got it as 0.33. Now let us see this column where in which fever is equal to y is given here, the data set, and we are checking for both the classification. So fever y, we'll check how many, 1, 2, 3, 4, 5. 5 rows are there with fever y, and you need to check how many are there with the flu y. So this is one with flu y, this is again with flu y, this is again with flu y, this is again with flu y. So how many rows are there? 1, 2, 3, 4. 4 rows are y and flu y. So you will be getting 4 divided by, here it is 5. So 4 divided by 5 you got. Now check flu y and fever y and flu no. Fever y is this one and this is flu no. So here this is one, fever y and flu no. Then fever y and flu no. So only one is there. So 1 upon 3 you got it there. So you got all the probabilities for the given sample set X. So X is given, and from that you got the probability for each classification. Now in next step, what we have to do is we have to multiply it. So for S, this is S, this is flu S, this is flu S, this is flu S. Similarly, this one is no. This is the probability for no. This is the probability for flu no. This is the probability for flu no. So you got the probability for both the cases. Now what we do? This is the given data set. Okay. Now the probability of X on given CI. X is what? This one. X is already given. This is a given data set on classification. So what are the classification? You have only two classification. One is X given, flu is equal to X, and the second one X given, flu is equal to no. So how will you find X given, flu is equal to S? So you got the probability X given. X is what? One is this chills, then one is runny nose, another one is headache is equal to mild, then fever is equal to Y. You count all, you just see the probability of all S cases. So whatever I tick marked here, just take the values, that is 0.6, then 0.2, then we have 0.4, then 0.8. Multiply all those things to get X on S. Okay. So similarly, you take all the values for no, that is 0.33, 0.66, 0.33 and 0.33 and multiply that. So you'll be getting X on no case. Okay, so you will be getting both the probabilities. So X on flu, what we have done, we have taken all the S cases and multiplied. For flu, we have taken all the no probabilities and multiplied. You got both the values. Now what is the final probability? Because you have found this one here, what is that one in the equation for Ney-Bayes theorem? So Ney-Bayes theorem, when you are talking about this, is you have to multiply it with the original probability, that is probability of C. What is the probability of C we have found initially? What is that one? That initial probability is this two things, that is P of C, that is 0.625 and 0. So for S probability, you multiply this original probability, and for no probability, you multiply this 0.375. So here, this is the equation what we are doing. So what we have got here, we are multiplying it with the probability of flu S probability, that is 0.625 here. But this value you are multiplying with the original probability for no, that is 0.375. So you got two answers here. Now you got all the probabilities. Now what you have to do, what is this one? This case for given sample data set, the flu S classification, and this is for the sample set X no classification. So out when you compare these two probabilities, 0.024 and 0.0088, we know that this 0.24 is greater than 0.008, this one. So since this value, that is, what is that one? That is the probability of S given. The classification is S, flu is equal to S. So since that probability is higher than flu is equal to no classification probability, the classification is that if this data set or this sample is given, then the prediction should be flu is equal to S. So this is the classification. So for the given data sample, the classification we have already got it as S. So this is how we use Ney-Bayes classifier to classify the given data set. And you can use the same naive-Bayes classifier in a similar way. You can use to solve various problems wherein which you can classify it as male, female, or you can make spam, not spam, or whether when it is raining, the for weather forecast, whether a game will happen, whether that player will play or not. This type of problems you can do using this naive-Bayes classifier. But one thing you need to remember is that, as you can see here, this one is when we are multiplying all this probability. Suppose any of this probability is 0, then what will happen? Your complete answer becomes 0. So do you think that this, when you are multiplying some non-zero value with the 0 and the final answer is becoming 0, then the answer won't be correct. So if there is any 0 probability cases, then what you have to do is you have to use the Laplacian correction method, so that you have to avoid the 0 probability problem. How you will be doing this Laplacian correction? What you can do is, every probability, when you're applying this naive-Bayes classification, every probability should be a non-zero value, because if there is a 0 value, when you are multiplying, the complete answer becomes 0, which is not correct. So suppose, for example, suppose you have 1000 tuples, okay, and you have an attribute income with the low, income is equal to medium, and income is equal to high. So under income column, okay, income column, suppose you have high, medium, and low. Okay, so what is happening is the number of tuples with this income high, medium, low. In this low, it is this, there is 0 tuple, that is in income low, there is a probability is becoming 0. So what you have to do is, we will be simply increasing, we will be adding one row, and we will make that income is equal to low in that particular case. So we are adding an additional row with income low. So when you are adding an additional additional row with income low, similarly what you have to do is, since we can't simply increase one attribute value, so what you have to do is you need to increase for medium also, you increase one value, one row extra you add it, and for income high also you add one row extra. So how many tuples were there? You were having 1000 tuples previously. So for income low, you have considered one tuple with a non-zero value. So plus income medium also, you will be making instead of medium 990, right now we will be having 991 tuples, plus income high you will be having 11. So when you are doing this, we'll be getting here, this one is, this instead of this 1000, you will be having now 1003 values. Okay, so here we'll be having this 990 plus 10 is what? 990 plus 10 is 1000. So 990, now we have here this one. So now previously we have 1000, so we'll be doing 1000 plus 3 here. From where this 3 came? Because this is not plus, 1000 plus 3 came from this 3 came from 1 for low, 991, because one row we added for medium also, so 990 become 991, and for high also we added one extra row, so instead of 10 now you have 11, so one extra here, one extra here, one extra here, so 1000 plus 3. So total tuples now you have 1003. So when you are doing the probability of income low, it became, now previously it was 0 upon 1000, now it became, because one row we included for low income, so it became 1 upon 1003, 991 upon 1003, and 11 upon 1003. So in this particular case, we have removed that 0 probability case. So basically this corrected probability estimates are closer to the uncorrected counterparts. Why? Because these values are closer to the values, the actual values, because if it was 0 means everything, when you are multiplying, the complete answer becomes 0, which is incorrect. So when you are doing this Laplacian correction or Laplacian estimator, the values which we get is closer to the correct value. That is why this is how you have to avoid 0 probability problem. So whenever a probability, whenever any row is becoming 0, then you have to add an additional row and do it for all the particular the classes belonging to that particular attribute and find the probability. So this way you can avoid the 0 probability problem. I hope you understood how to use a naive-Bayes classifier for classification problems. Thanks for watching. Thank you all.